Okay, so we're going to do a couple more examples of the oblique asymptotes. And again, maybe you've already done them, you just want to check your work, which is awesome. But remember, it has to do with doing long division. And so the degree has to be exactly one higher. So I look here, x cubed is one higher than x squared. So I know there's going to be an oblique asymptote. And I didn't really say anything about this in the last video, but because you have an oblique asymptote doesn't mean you can or can't have a vertical asymptote, because I never really checked the denominator. But if you have an oblique asymptote, realize that you can't have a horizontal. Because remember, for a horizontal asymptote, if the bottom wins, right, if the bottom is bigger than the top, then y equals 0 is the horizontal asymptote. If there's a tie, then it's equal to the ratio of the coefficients. But now if the top is bigger than the bottom, it can't be in either of those two cases. So like having an oblique asymptote means you can't have a horizontal one. And having a horizontal one means you can't have an oblique. So I just want to make sure that we are okay with that. So let's go ahead and do our long division, or maybe you've already done that. I don't know. So we'll divide x squared plus 4x plus 1, and we'll divide that into 3x cubed minus 2x squared plus 6x plus 5. Okay, so then we get x squared dividing into 3x cubed. That's 3x times. So 3x times x squared is 3x cubed, and that's plus 12x squared plus 3x. Now, remember, we subtract. I'm going to subtract that. And so then, I want that to cancel. So 3 minus 3 is 0. That's the whole point. Negative 2 minus 12. So that's negative 14x squared. 6 minus 3. So that's normal 3. And then bring down your 5. So plus 5. And then we repeat. So x squared goes into, negative 14x squared, negative 14 times. So negative 14 times x squared is negative 14x squared. Negative 14 times 4 is negative 56x. And then negative 14 times 1 is negative 14. And again, remember, we subtract. So I'm just going to highlight that in red. And then we take a look, see what happens. That cancels, so that's a 0, so that's good. 3 minus negative 56 is a positive 59x. And then 5 minus negative 14 is positive 19. So remember, where do we find the asymptote? The asymptote is in the whole number, or the part that divides evenly. And it's a little deceiving because the remainder, which is sitting down here, right, that looks linear as well. But remember, that's the remainder. The asymptote is up here in yellow. So then I could say the equation of my oblique asymptote was equal to, I guess I'll go green, y equals 3x minus 14. And again, think about, what does this mean? That means the graph of the function that we started with will begin to behave like that linear function as you start to look at its endpoints. Okay, so then we see our next example, example C, and we have 2x cubed over x to the first. Well, this is great, because if it's 2 degrees more, right, even though I can do long division, it's 2 degrees more, there's no longer an oblique asymptote. So there is no oblique asymptote. And I think I maybe even mentioned this in one of the earlier videos, that because it's actually 2 degrees higher, it's actually the asymptote is actually a quadratic in nature, and that's a little bit beyond our scope of our class. So for us, there's no oblique asymptote. It's 2 degrees higher. There's no horizontal. Just for fun, I know there is a vertical asymptote, right? X can't equal negative 4, but the question says find oblique. Okay, and then I think there's one more here. And so again, you could try to do this on your own. Pause the video and see how you do, and then check it. But I do know that's 1 degree higher. So then I'll do my long division. So I have 2x squared plus 4x minus 1, and I'll divide that into 6x cubed minus 6x squared plus 4x plus 7. Okay, so 2x squared into 3x cubed, that's 3x times, 3 times 2, 6, x cubed. Go ahead and carry out the rest of the multiplication. That's negative 12x squared minus 3x. And then don't forget to subtract. So we'll do that. We get our 0. That's the whole point of the division, is we want to cancel that factor. -6 minus -12, that becomes a positive 12. So it's plus 6x squared. 4 minus -3, so it's actually a positive 7x. And we carry down our 7. And we repeat one more time, looking at 2x squared going into 6x squared to be plus 3 times. So 3 times 2, 6x squared. 3 times 4 plus 12x. And then 3 times -1, sorry, -3. And then again, one more final reminder, I'll write it in red, we subtract. So 6 minus 6, we want that 0. That's how we know it canceled. And then 7 minus 12 becomes -5x. And one more, be careful, 7 minus -3 becomes positive 10. Looking at the location, the asymptote is up here, right? Highlighted. Oops. Well, I guess if you're OCD like me, you want the right color. So let's go back to yellow. There it is. That's our asymptote. And remember, this down here is just the remainder. And you might be asking, wow, Mr. Brown, we've gone through 4 examples and we've talked about the equation of the asymptote, but we really haven't said anything about the remainder. And you're absolutely right. We haven't. But that is that is something that's going to be really important, and we're going to see that. What can that remainder help us find in our next video? But again, I just want to emphasize, how do you get those oblique asymptotes? You do long division. Be very careful. Cannot stress how you have to be very clean in your long division. Keep things lined up in terms of the degrees, and then always it's in the quotient up here. What would be your equation of the asymptote? Okay, so again, take some time, look at your notes, go back, process this, and then we'll see what kind of questions you have, in class tomorrow.